Hello everybody, Assalamualaikum warahmatullahi wabarakatuh. Today we are going to talk about public transport. Now it is very common, if you go to any big cities, you can see rail-based public transport. We have mass rapid transit, we have light rail transits, we have people rapid mover. At least in Kuala Lumpur we have this kind of public transport. So for the MRT, usually the speed up to 100 km per hour. The number of coaches between 4 to 12 per train, and the size of coach is 22 meters long and 3.1 meter width. The capacity of the train up to 80,000 passenger per hour per direction. Acceleration is 1.2 meter per second, and the rails usually standard gauge, about 1,435 meter gauge. Headway usually not less than 120 second. And then because of the bigger capacity, it is suitable for radial movement from suburban to the city center, and suitable for high density and high plot ratio area. High density, that means residential area, which consists of more than 300 people per acre, and high plot ratio usually more than 5. That means the floor area is 5 times of the land area, and we need feeder bus service to ferry passenger to the final destination, and usually power supply is 750 volt direct current, and you need substation for electrical supply, but between 3 to 5 kilometer spacing. You cannot provide more because the voltage drop will be quite high. And we have light rail transit, speed up to 40 km per hour compared to MRTs to 100. This only 40 km per hour. The number of course is between 2 and 6, and the capacity up to 40,000 passenger per hour per direction, and the acceleration is 1.2 meter per second. Usually rail gauge between 1 meter gauge to standard gauge 1.4 meter gauge. Headway is 120 second, and because of the capacity quite high, it is suitable for radial movement, and also for high density and high plot ratio area. And we need also feeder bus to ferry people to the final destination. The power supply is 750 volt direct current, and we need substation between 3 to 5 kilometer spacing. And also we have people mover rapid transit, people mover rail transit, speed up to 30 km per hour, the number of coaches between 2 and 4 per train, capacity up to 10,000 passenger per hour per direction. Rail usually for 1 meter gauge, headway not less than 90 second compared to the LRT MRT 120, but this one 90 second headway, and suitable for intra city travel, inside the city travel. And we can calculate the transit capacity using this formula. This is a quite logical formula. You have maximum passenger per vehicle, and you have headway. So that thing, if you just divide between divide maximum passenger per vehicle per headway, let's say for 2 minutes. So then because of this, this one very theoretical, but this one operational design, so we have to include the gauge utility factor 0.6 and load factor 0.9. Actually this one to cater for peak hours, or for sudden surge in demand. This is an example. Let's say City Hall of Kuala Lumpur intend to provide a transit line to meet peak hour demand of 12,000 passenger per hour per direction, and the required speed between 35 to 40 km per hour. Minimum headway is 120 second and maximum headway is 240 second. Guideway utilization factor 0.6, in-load factor 0.9 second. Station platform is limited to 10 vehicle, and vehicle capacity is 130 passengers. So this is a typical LRT service in Kuala Lumpur. So we just use that formula, this one. This one. So we just put the capacity, the demand is 12,000. This is the real utilization factor, everything. Hence this the number of vehicle per train, and this one the passenger per train, the number of passenger per vehicle, and this is the headway. And we simplify the formula something like this. So we can put, if we put one coach per train, unit headway 20 second. If we put 6 vehicle per train, unit the headway 126 second. So if we put 10 coaches per train, you can have 210 headway, 210 second. So more than 10 cannot, because our station is limited to 10 vehicle, and less than 6 also cannot, because we need the headway less than 120. Anything less than 120 is quite dangerous, because the second train can hit the first train while stopping at the station. Now let's look up to the bus service. Normal bus service usually can carry quite a lot of passengers, about 240 passengers, and it is very good because it is very flexible. You can go anywhere in the city, as long as there is road network. The bus can go anywhere. But if you design the bus as transit service, something like bus rapid transit, you can go up to 15,000 passenger per hour per direction, even up to 30,000, up to 30,000 if you design the station big enough and can stop up to 2 buses or 3 buses. You can go up to 30 passengers per hour per direction. That's why the bus rapid transit or bus transit now become very popular, because it is much cheaper compared to LRT, and faster for the planning and construction period. And for bus travel pattern, we can give bus service for radial service between suburban to CBD, like shuttle bus, or ring road service to link up various sub-center, or local travel service like minibus in the suburban or sub-area, and special travel in the CBD, e.g. for example for tourism, and of course travel service between activity center, shuttle service between activity centers. And we have to prepare a bus service guideline, because we have to make sure the bus give the quality service. For example, this one, service pattern: service major cap activity center such as an office building, school and hospital, provide 300 meters coverage where population density is more than 30% per acre, serve at least 90% of the resident, and space route at about 0.75 kilometer in urban area and 1.5 kilometer in suburban area. So that means if we have parallel bus service, the space is about 0.75 kilometer. That means one bus service cover a corridor of width 1.5 kilometer for urban area, and suburban is 3 kilometers corridor. This one actually based on the survey done in temperate country, but in Malaysia maybe less than this, because people less willing to walk compared to the temperate countries. Okay, about service level, service period between 6 a.m. in the morning up to 12 p.m. at night, and headway at peak 5 minutes, off peak 15 minutes. This is only example, but for the bus rapid transit, usually this one 2 minutes, 2 minutes. And bus stop, city center usually up to 7 stop per kilometer. In suburban area, up to 3 stop per kilometer. And passenger comfort, passenger shelter like this, unit passenger shelter, especially for the tropical country like Malaysia. Route and destination sign, so people will not get lost. Driver courtesy. This is an example of bus terminal or bus stop. This is the major road, so the bus can stop here and then go again, and from this direction, and stop here, load and unload passengers and go again. Or the bus can, alternatively, the bus can stop here for a while. Or this design with the LRT station or metro station under the ground, so the bus stop on the surface, so the bus can from this direction can go in here and unload the passenger, and coming this one, and then stop here to load the passenger and then go again. From this direction, so the same thing. You can go something like this, and then the same thing, unload passenger here and then load a new passenger here. This is an example of bus station above the underground transit station. I took this picture in Madrid about, I think, six years ago. So underneath of this bus terminal is actually a metro station. And to make bus more attractive, we have to reduce the travel time. So we give a priority lane along the major roads, along the roads, and we produce this kind of traffic light configuration, so the bus can go to the front line at the road approach, and then go faster. Let's say we have two line of traffic light here, so for these 2 lane we put red, so every other vehicle will stop, but the bus, through the bus lane, it is green, so the bus can fill up this front area, and then when it is green, the bus will go first. And this is an example of bus lane. I took this one in Geneva about, I think, seven years ago. Okay, now bus operation design. Of course, we have to provide bus service based on the demand. If the demand is too high, our bus will be very crowded. If the demand is too low, and maybe it's not viable to give bus service. So this is a logical formula. The frequency is equal to demand for service in terms of passenger per hour, and capital letter uppercase is maximum number of passenger per bus. This is very logical, and usually minimum headway is set in multiple of 7.5 or 10 minutes for the sake of coordination, or service frequency of 6 per hour. Example: a bus service is planned between Bangi and Putrajaya, a distance of 20 km. The operating time is 45 minutes. Estimated demand is 500 passengers per hour. 40 side-seater buses will be used, which can accommodate 20 standees. So the number of passengers is 65. Design a basic system and determine the fleet size. Maximum headway is 30 minutes and the minimum terminal time is 5 minutes. Okay, now the operating speed is the length of travel divided by time. This one, L divided by T. 60 actually to convert to kilometer per hour. So now you have 20 kilometer, and we have 45 minutes. So the 60 is to convert from minutes to hour. So the operating speed is 26.67 kilometer per hour. Headway equivalent to the number of passenger divided by demand. This 60 actually to convert to minutes, from hour to minutes. So now our headway is 7.8 minutes. So we adopt 7.5 minutes, because 7.8 minutes is very difficult to monitor. 7.5 is quite easy. 7.5 multiplied by 2 is 15. Multiplied by 4 is 30, something like that. 30 minutes. So easy for coordination. And cycle time, we have 25 minute travel, and we have 5 minutes terminal time, multiplied by 2 because go and back. So we have 100 minutes per cycle. And fleet size, we have the cycle time, and our headway is 7.5 minutes. So the cycle time, but just divide by the headway, you can get this one, 14 vehicles. So you have to revise the cycle time based on this 14 vehicle. Now the cycle time is 105 minutes. 105 minutes. Okay, quite okay. And reverse terminal time, reverse cycle time minus this 2 travel time divided by 2, so now 7.5 minutes. So now okay, because the minimum is 5. And the commercial speed, you just divide, but the distance with the time, so now is 22.86 kilometer per hour. Okay, thank you very much.